Hey class, we are going to do more factoring binomials that are special cases. Let me move my camera over here. There we go. Okay, so factor binomials that are the difference of two squares, two perfect squares. This is another special case. Okay. So what I mean by perfect squares, y'all remember what perfect squares are? They're numbers that come from something times itself. So let's say we have 3 squared. 3 squared is 9. So 9 is a perfect square. So if I look at this, I have 9 squared minus 81. So if I don't have a middle term here, so that's different. Also, this is a square, and then 81 is also a square. So if I take 9 squared and take the square root of it, square root and squared are opposites, so they cancel each other out, and so that's n. And then I take 81 and I take the square root of that. And that actually, to get 81, you do 9 times 9 or negative 9 times 9. So this is 9 and negative 9. So that means I'm going to do n and then do plus 9. Because I'm going to use that as my first term. This is my second term. And then another binomial, which means two terms grouped together, is n minus 9. So look at that. Whenever we multiply these out, we get n times n is n squared. I guess I could show y'all real quick so that we make sure. Let's see. If I do n 9 and n minus 9, if I do this, n times n is n squared, and 9 times n is 9n. Then I do negative 9 times n, that'd be negative 9n. And negative 81 times 9 is negative 81. Negative 9 times 9, I don't know if I said that right. So if we look at these two, what happens when we have a 9 minus 9? It becomes 0. So the only thing that you have left is n squared minus 81. Okay, so if you see that it's two squares, there's no middle term, and it's the subtraction sign is right here, then it's one of these special cases. Okay, so let's look at the next one. So this is what the answer is. All right, let's see if I can find a different color. I have a squared minus 121. So I don't have that middle term, so I know it might be a special case. So if I had a squared, if I take the square root of that, then that's a. That pen is no good. I'm going to throw it away. Let's find a different one. Is the same? No, different color. And then I take square root of 121, and I get 11 times 11, and also negative 11 times negative 11. So that means that this is my first term. These will be my second terms. So this will be a plus 11, a minus 11. Hopefully you're getting the hang of it. Okay, let's look at the next one. N squared plus 16. This is addition. That's not difference of squares. So this is going to be prime because there's nothing that you can do to get rid of the middle term. So this is called prime whenever it can't be factored. Cannot be factored. Okay. The next one, we have 25x squared minus 9. So the first term, that's a 25x squared. If I take the square root of that, it's like taking the square root of 25. What times itself gets 25? And that's 5. And then x squared, take the square root, it's 5x. So this will be my first term. And then my second term, what's the square root of 9? It's going to be 9 and negative 9. So these are my second terms. So this is 5x plus 9 and 5x minus 9. Okay, so the difference between this one and all the rest of them is this is addition. Whenever you get an addition problem here, then that means they're both positive or both negative, and you would have a middle term. But here, the -9 tells me that one of these terms will be positive and one of these terms will be negative. And look, I just made a mistake. I just saw it. Look at me correcting my own mistakes. It should be 3 and -3. I know I was about to get some emails from some people that I messed up. Gosh, I'm glad y'all tell me that when I mess up. Oh, so this is there we go. Okay, so why is it 3? It's because it's square root of 9. Square root of 9 is 3 because 3 times 3 is 9, and square root of 9 is -3. There's actually 2 answers when we do a square root, the positive and the negative. All right, let's look at this next one. 4x squared, and it's subtraction. This has a variable, this one doesn't. They're both perfect squares. 4x squared, if you take the square root of that, that's 2x. And then 49 is 7 and -7. So this is your first term. These are your second terms. So you're going to write it as 2x plus 7 and 2x minus 7. Okay. The next one, k squared minus 100 equals 0. So that means, what's the square root of k squared? Equals k. And what's the square root of 100? Positive 10 and -10. So that means this will be k plus 10 and k minus 10 equals 0. So when you solve this, you do k equals 10. K plus 10 equals 0. And k minus 10 equals 0. So you do minus 10, minus 10. So k equals -10. And then here, plus 10, plus 10. K equals positive 10. So you have those 2 solutions. The next one, 9c squared minus 1. So if I take the square root of 9c squared, the square root of 9 is 3. C squared will get c. And then 1. What times itself gets 1? Well, it's 1. So 1 and -1. So this means it's 3c plus 1 and 3c minus 1 equals 0. So then you solve each one of them. So 3c plus 1 equals 0 and 3c minus 1 equals 0. So we subtract, let me cover this up. We subtract 1, and that gets 3c equals -1. And then we divide by 3. I did not leave enough room there. So c equals -1 over 3. And then the other one, plus 1, 3c equals +1. Divided by 3, c equals 1 over 3. So those are our 2 solutions. -1 over 3 and +1 over 3. Okay, next one, 9x squared equals 36. Well, we need to subtract 36 from both sides. So minus 36 equals 0. Okay, so then we look and see, if I look at these are perfect squares, but they have something else in common. They have 9 and 36. They actually have 9 in common. We can pull out the GCF of 9. So 9x squared minus 4 equals 0. So then we have, let's see, this is a squared and this is a squared. So we do 9. The square root of x would be x, so that's my first term. And then my second term, -4, the square root of 4 is positive 4. So this is going to be positive 4 and negative 4. So it looks like that equals 0. So in this case, this 9 equals 0. That's not a solution. But each one of these is going to be a solution. So x plus 4 equals 0 and x minus 4 equals 0. So minus 4, so x equals negative 4. And then minus 4 here, so we do plus 4, x equals 4. So our two solutions is x equals 4 and x equals negative 4. Okay, the next one, and this is our last one, we are going to do, so 16x squared equals 64. You can move this over. So 16x squared minus 64 equals 0. Let's look at those. 16 and 64, they have something in common. They're both evens, but they're actually more than that. Zoe is trying to get up here. She scratches me until I pick her up. She's such a brat, spoiled brat. Zoe is. So then 16 can be pulled out, and this would be x squared minus 4 equals 0. So then this is actually the same as that. So x squared, square root of that would be x, and square root of 4 is 4, and the other one is minus 4. So 16 doesn't equal 4, so that's not a solution. But this x plus 4 equals 0, and x minus 4 equals 0. So we do minus 4, x equals negative 4. Then we do plus 4, x equals 4. So we have these two solutions. Oops, just like the last one. All right. I will see y'all later. Bye.